Hello everyone, this is Heather Sprague, giving you the high five for the flood risk calculator. Why was it created? I'm hoping the why we evaluate flood risk is obvious to everyone, but in case it's not, flooding is bad. What you see here demonstrates the effects of coastal, riverine, and stormwater flood risk. We know that these hazards are only going to get worse with climate change, so if we want to understand how to make things better in the future, we need to first understand where we're at and figure out a path to get us there. About 15 years ago, to perform a reliable flood risk assessment, we built out a custom spreadsheet model that gives us more flexibility than what's available using other industry software. Over time, we turned the spreadsheet model into a Python tool to do the same thing, but in a cleaner, more efficient, and more reliable manner. This Python tool is what we now call the flood risk calculator, or the FRC for short. This tool uses standard FEMA and Army Corps methodologies, but its granularity and flexibility allows us to glean new insights into the picture of risk in an area. What is it? When we talk about assessing the impacts of flooding, there are several different layers of analysis that build upon each other to bring us to a full picture of risk in an area. We start by understanding the exposure of an asset, such as a home or a business, to a specific flood event. For instance, is this asset physically located in the floodplain? We then think about the vulnerability of that asset. Is it elevated? Does it have key components that might be negatively impacted if they were to get wet? Next, we work to quantify the consequences of that vulnerability, often by using industry standard depth damage functions for various asset types. So for instance, a single family home is going to experience different consequences than, say, a wastewater treatment plant with the same level of flood depth. These depth damage functions help us to arrive at impacts in terms of dollar values per event. Then, to go from consequence to risk, we look at the intersection of consequences and probability, estimating impacts from a range of different events with varying probabilities, and basically finding the weighted average to get a term called the expected annual damage, which tells us the risk that we might expect in any given year. I want to caveat all this by saying that dollars aren't the only way to quantify risk. We're also looking at other metrics, including impacts to the most vulnerable populations impacted by a flood hazard. So, the flood risk calculator combines GIS and tabular data using Python scripts to evaluate these impacts of individual flood events on buildings within the floodplain, as well as these bigger picture climate change impacts for project areas ranging from small neighborhoods to large metropolitan regions. The FRC estimates damages at the building scale across a handful of different metrics, including direct physical damages to buildings and their contents, human impacts like shelter needs, impacts on mental stress and lost productivity, as well as the disproportionate impact of physical damages on low-income residents, residential displacement and temporary business relocation costs, impacts of loss of service on certain public assets, such as police stations, fire stations, or hospitals, direct business interruption in terms of lost economic output, and it spits out inputs to model indirect business interruption using an external program called InPlan. Who is it for? Our clients are typically local, regional, or state agencies looking to make the best investment decisions for flood resilience and to more effectively communicate and substantiate these decisions to gain and retain community buy-in for proposed capital projects. By using the FRC, Arcadis has helped communities from New York City to Tarpon Springs, Florida, to San Francisco quantify billions of dollars of avoided losses, supporting project and policy alternatives. In the last 5 years, we've used this tool on over 30 projects across 12 states, and we're still going strong. Where has it been used? One use case for the FRC was for the Coastal Resilience Solutions for East Boston and Charlestown project, where we used the FRC to understand the distribution of risk across two socially vulnerable neighborhoods of Boston. One of the interesting complexities in this project is that we have a coastal floodplain originating from multiple pathways, leading to widespread flooding of residential areas. We know that we need to implement adaptation measures across all of these potential flood pathways to effectively reduce long-term risk. We also know that we can't do this all at once, and that we need to prioritize which of these measures is needed first and gives us the biggest bang for our buck. So, using the FRC, along with some detailed coastal flood modeling, we were able to determine how much risk reduction we could attribute to each adaptation measure. This analysis is just one example of a space where we were able to dig deeper into our results than we would have with any previous methods. Why should I use it? The FRC can help you and your client understand how flood impacts change over time, answering questions like what neighborhoods and industries are most impacted by stormwater flooding, or how does our risk change if we get 3 feet of sea level rise by 2050 instead of 2070? The FRC can help substantiate the benefits of a proposed adaptation project and is often used to compare alternative flood mitigation alternatives within a region. Whether it's to support a benefit cost analysis for a federal grant application or to support local or regional scale adaptation planning, the FRC is our go-to in-house tool for quantifying flood risk throughout the country. How can I use or integrate it into my work? Our standard process for running the FRC starts with understanding the need and gathering data about the area, including flood extents, building footprints, structure uses, and first floor elevations. Our team includes GIS experts, resilience planners, and water engineers who are skilled at creating and analyzing large data sets to distill them into insightful and actionable recommendations. Please feel free to connect with me or anyone on our team to discuss the requirements and needs for your project. Thanks!